I'm sorry, you have lung cancer. It's the most common type, called non-small cell lung cancer. But with surgery and chemotherapy, you have a 1 in 5 chance of surviving 5 years. Imagine hearing those words. Over 2 million people around the world hear them every year. Lung cancer is the leading cause of cancer-related deaths, killing 9,000 Australians last year. Patients receiving chemotherapy and radiation will endure terrible side effects. But the patient isn't the only one with the drive to survive. You see, lung cancer is clever, and just like Google Maps, it's always searching for alternative pathways to survive and grow. Now, cancer drugs work like roadblocks. They block nutrients, cut off blood supply, and they even set traps to make cancer cells self-destruct. But lung cancer finds new pathways. It adapts and it spreads and it sets up new colonies in other organs. This is called treatment resistance and metastasis. It's exactly what makes non-small cell lung cancer so deadly. And this is where my research begins. For thousands of years, plants have been used to treat lung disease. Today, we can isolate their powerful molecules called phytoceuticals. For my thesis, I'm exploring compounds from plants like phycetin from strawberries, because research shows they do have anti-cancer effects. But we have a problem. Compounds like phycetin are poorly absorbed. They don't travel well in the body. It's like trying to drive somewhere new with no directions. So we wrap them in tiny delivery vehicles called nanoparticles. These help the body absorb the molecule and drive it straight to the tumour. But let's not stop there. In our bodies lives an entire workforce, trillions of organisms called the gut microbiome. These microbes influence tissue repair in the lungs via the gut-lung axis. So in my lab, I treated human lung cancer cells with nanoparticles loaded with phycetin and an extract from the microbiome because I wanted to know, would there be a synergy that could increase the roadblocks? Well, the cancer cells seemed to lose their map. I measured how they responded. Their ability to replicate slowed, their movement slowed down, and most importantly, they couldn't form a new colony. My future research includes Australian natives like lemon myrtle. By unlocking nature's pharmacy and using nanoparticles to deliver precision medicine, I hope my research can redraw the roadmap of lung cancer treatment and disrupt lung cancer's escape routes, so those who hear those final words have better pathways. Thank you.